Hello everybody. I hope you've had a wonderful 24 hours. Hopefully you caught on to synthetic division. So last week we looked at long division. We started off yesterday with synthetic division, which is a form of long division, but it's just a shortcut method to it. Well, we're going to continue that concept of synthetic division, but today we're going to be looking at synthetic division. I can't talk tonight. Synthetic division in reverse with the remainder theorem. In other words, finding K. All right, I'll give you a second to copy that down. Now, make sure that you're putting your name on your notes and the date. Okay, so again, make sure that you're putting your name and the date on your notes. And then make sure that you are submitting your notes. Alright, so let's come right here and look at our first example. So here we're going to have x minus 2 is a factor of our polynomial x cubed minus 4x squared plus px plus 6, and they want us to find p. Now, although I said it's finding k, most of the time we either say find p or find k. K is the more popular one, but sometimes p will come up. Alright, so copy this problem down and we'll start on it in just a few seconds. Alright, so let's look at what they give us here. They tell us that x minus 2 is a factor of this polynomial. Okay, well, x minus 2 is in the form of x minus your root. So here we can see that our root is going to be a positive 2. Because remember, we always say the opposite when it's in factor form. So when your divisor is a linear binomial, that is in factor form. Okay. They tell us that this is a factor. Well, if it's a factor, that means your remainder is 0. So here, r of x would be 0. Or in other words, the remainder is 0. Now, today's notes are not guided notes, so you should be taking these in your notebook and submitting a picture of all the notes in your notebook. And I believe there are only 7 examples to get through today. Alright, now, why is it important that we know that this is a factor? It's important that we know this is a factor because we know that our remainder is 0. So let's go ahead and set up our synthetic division. Okay, we draw our box. Our root is 2. Our coefficients, let's see. I'm going to use pink here. Alright, so we got a 1, a negative 4. P is a coefficient. Even though it's a variable, it's a value in front of the x. So it is a coefficient. So P and then 6. Draw your bar. Okay, so again, 1, negative 4, P, 6. Alright, so this looks like synthetic division, just like we were doing yesterday. So let's go ahead and drop that first number. So drop in the 1. 2 times 1. Remember, anything below your bar, you multiply by your root. So 2 times 1 gives us a positive 2. Negative 4 plus 2 gives us a negative 2. 2 times negative 2 gives us a negative 4. But here we cannot combine these. Okay. And since we can't combine these, this is where we hit what I call the roadblock. Okay. So this is your roadblock. And it's your roadblock because you can't combine them. You have to stop right there. You can't work forward anymore. So speaking of working forward and hitting a roadblock, we know that usually if we hit a roadblock, we can't go beyond the roadblock, so we have to turn around and go back to where we started with. So if you hit a roadblock, you're going to have to work backwards. Now, what do I mean by this? All right, so this is where knowing a factor, that this is a factor, comes into play. What do we know the last number is going to be since it's a factor? The last number is going to be your remainder of 0. So right here, this last number is a 0. Remember we talked about that whatever that last number is, that's always the remainder. Since it's a factor, the remainder is 0. So working backwards. Okay. What can we combine with a positive 6 to get a 0? A negative 6, because 6 minus 6 is 0. Now, when we were working forward, we had to multiply down here, anything down here by the root. Okay, well, since we're working backwards, instead of multiplying, we're actually going to divide. Okay, so I need to figure out what this right here is. So in order to figure that out, think about this. You had to say 2 times this value to get that. So now we're going to divide negative 6 by 2 to get this right here. So working backwards, instead of multiplying like we did when we worked forward, we're going to work backwards and divide. So negative 6 divided by 2 is negative 3. This creates your little simple equation right here. We now know all the values there. Once you create that simple equation, you can solve it. We've got p minus 4 equals a negative 3. So I'm going to add 4 to both sides. Negative 3 plus 4 is 1. So our missing p value is 1. Let's try another one. Let's say that we're given x plus 2 is a factor. Now sometimes they might not have the full set of directions, but you always assume it's a factor unless you're told otherwise. Okay? So x plus 2 is a factor of the polynomial 2x cubed plus x squared plus kx plus 2. Alright, I want you to take about 40 seconds and I want you to set this up. So take 40 seconds and set this up. About 10 more seconds. Alright, so let's see how you did. Alright, now since this is a factor and it's a linear binomial, which means it has 2 terms, it's in the form of x minus our root. So our root here is going to be a negative 2. So right here we're going to put a negative 2. My coefficients, all right, let's see, we got 3, 2, x, 2, so everything's in standard form. So we got a coefficient of 2, coefficient of an understood 1, coefficient of k, and then a coefficient of 2. Draw our bar. So we're going to drop the 2, because we always drop that first number, and then we start our multiplication. Negative 2 times 2 is a negative 4. 1 minus 4 is a negative 3. Negative 2 times negative 3 is a positive 6. But we can't combine these right here, so there's our roadblock. So again, we've hit a roadblock. And when you hit a roadblock, you got to work backwards. So we're going to start at the end and work our way back. Okay, so since this is a factor, I know that my last number is going to be a 0, because if it's a factor, the remainder is always 0. Ask yourself, what can you combine with a positive 2 to get a 0? Well, that would be a negative 2, because 2 minus 2 is 0. Working forward, we multiply, but since we're working backwards, we've got to divide. So we're going to take this number and divide it by our root. So negative 2 divided by negative 2 gives us a positive 1. Here is our simple equation that we need in order to solve for k. So we're going to say k plus 6 equals 1. Alright, subtracting 6 from both sides, we're going to get k equals a negative 5. Now, you're going to find on the EOC that a lot of times they'll ask the same thing, ask you to do the same thing multiple times, but they're just going to ask you in different ways. Okay, so like for example, if I came right here and said, if p of negative 2 equals 0, find k for p of x equals x cubed minus kx squared minus 6x plus 8. Alright, now that you got this copied, see if you can figure out how to set it up. P of negative 2 equals 0. Find k for the polynomial x cubed minus kx squared minus 6x plus 8. So take about 15 seconds and set this problem up. Alright, now let's see what we got going on right here. Notice this right here, this is not in factor form. This is telling us that your input of negative 2 would give you an output of 0. So that must mean this is the root. Okay, so when you substitute in your root, you get a remainder of 0. So this is the remainder, and this is your root. It's the same format as x plus 2 right here, x minus your root. It's just that they don't put it in factor form. This right here is in factor form, this is not. But if I put that in factor form, I would have x minus my root of negative 2, but negative gives us a positive. So they're just giving you the same problem, but just a different format of it. So we know that our root is negative 2, and our coefficients are understood 1, a negative k, a negative 6, and an 8. Join our bar, drop in the first number, so drop in the 1. Negative 2 times 1 is negative 2. There's our roadblock because we cannot combine these, so we're going to start working backwards. since we are told that this is a 0 for the remainder, we know that 0 is going to be the last number. What can you combine with a positive 8 to get a 0? Well, that would be a negative 8, because 8 minus 8 is 0. Working forward, we had to multiply, so working backwards, we're going to divide. So here we're going to say negative 8 divided by negative 2. And that's going to give us a positive 4, because negative 2 times 4 is negative 8. Now here comes the hard part. We've got to ask ourselves, what can I combine with a negative 6 to get a 4? So think of negative 6 as a minus 6. What can you subtract 6 from to get a 4? Well, that would be a positive 10, because 10 minus 6 is 4. It's like a little puzzle here. All right, again, we're working backwards, we're going to divide. So 10 divided by negative 2 is a negative 5. There's our little simple equation. So we're going to come right here, we're going to solve that. So we got negative k minus 2 equals negative 5. I'm going to add 2 to both sides. So we get negative k equals negative 3. That's an understood negative 1 right there. So we're going to divide by negative 1. And we get k equals 3. So it's not too bad. It's still synthetic division. It's just that we have to work forward a little bit and then turn around and work backwards a little bit. Now for 1, 2, and 3, we were told that all of these were factors. So our remainder was always 0. So let's see what happens if your remainder is not a 0. So we got some different remainders here other than 0. And I'm going to kind of give shortcut directions here. Alright, so we got our polynomial, x cubed plus 5x squared plus kx minus 8. We've got our linear divisor, x minus 3. And here we're told that the remainder is going to be a 1. So write this down, and then let's get started. Alright, so if this is our factor form right here, it's in the form of x minus r, our root is going to be a 3. So right here we're going to put a 3. Alright, then our coefficients. We got an understood 1, a 5, a k, and our negative 8. Dropping that first number, 3 times 1 is 3, and that's a positive 3, so 5 plus 3 gives us 8. 3 times 8 gives us a positive 24, and here's our roadblock. We cannot combine these, so we have to stop. Now, we are told that our remainder is 1, so this time our last number, instead of being a 0, is actually going to be a 1. Now, we can't work forward anymore, so we're working backwards. So what can I combine with a negative 8 to get a 1? So think of it this way. What can you subtract 8 from to get a 1? And that would be a 9. Because 9 minus 8 is 1. Working forward would multiply, but now we're working backwards, so we're going to divide. So 9 divided by 3 is 3. We have now figured out what the little simple equation is. So let's solve that little simple equation. We got k plus 24 equals 3. Subtracting 24, we get k equals negative 21. Alright, so let me give you one to try on your own. And we'll kind of use the same directions as I did right here. Alright, so let's say that your given polynomial is x cubed minus 2x squared plus x plus k. Your binomial factor is x minus 2, and you're told that p of 2 equals 5. So that means your root of 2 will give you an output of 5. So notice this is not in factor form, so when we put it into the synthetic division, it's not going to become a negative 2. It's going to say exactly what this is, because this is the root. You don't have to figure out the root. They're saying, hey, the root is 2. So if you'll pause the video here for about 4 minutes, I want to see if y'all can figure this one out. Alright, so let's see how you did. Alright, so my root, we are told, is 2. Alright, my coefficients. We got an understood 1. We've got a negative 2. We've got an understood 1 again, because that's an understood 1 right there. And then we've got a k. Bringing down our 1. 2 times 1 is a positive 2. 2 minus 2 is 0. 2 times 0 is 0. 1 plus 0 is 1. 2 times 1 is 2. And this one's going to be kind of easy. What do we know the remainder is? The remainder is 5. So there's our little mini equation right here. So yes, I did give y'all an easy one for you to try. So we got k plus 2 equals 5. So when we subtract 2 from both sides, we get k equals 3. Now, what we just did here is our synthetic division in reverse. I'm going to also show you with this problem how to use the remainder theorem to figure out what this could be. Because some of you might like synthetic division, some of you might like using the remainder theorem. I don't care which method you use as long as you show your work. Remember, no work, no credit. So coming right here using the remainder theorem. The remainder theorem says that when you substitute in your root, you're going to get your remainder. So again, when you substitute in your root to your polynomial, you get your remainder. Well, what do we know a remainder is? A remainder is 5. So I'm going to come right here and I'm going to replace p of x with 5. My polynomial is x cubed minus 2 times x squared plus x plus k. So basically what you're doing is you're taking your remainder and you're going to set it equal to your polynomial, and then wherever that's an x, you're going to substitute in your root. So my root here is 2. Alright, so let's see. 2 times 2 times 2 is 8. 2 times 2 is 4 times negative 2 is negative 8. Then we got plus 2 plus k. Now notice, once we substitute in, we only have one unknown, and that one unknown is your k. And that's the way it should always be if you substitute in correctly. 8 minus 8 is 0, and we're left with 5 equals 2 plus k. So subtracting 2 from both sides, we get k equals 5 minus 2, which is 3. So no matter which method we did, we got an output, or we got a k value of 3. Alright, let's do one more together, and then I'm going to give you a U-try, and we'll call it a day. Alright, we're given the following polynomial. We're going to do both methods. We're going to do synthetic division, and we're going to do remainder theorem. Alright, so let's start off with the remainder theorem. Synthetic division. Alright, if your binomial factor is x plus 2, that means our root is a negative 2, because you always take the opposite when you pull it out of factored form. If it's not in factored form, then you don't take the opposite. So here, they give us the binomial factor, but they're also telling us that the root here is negative 2. So we got a root of negative 2. A coefficient of 1, coefficient of k, coefficient of negative 4, and a 2. Dropping that 1. Negative 2 times 1 is negative 2. We can't combine these, so we hit that roadblock. So we're going to start working backwards. You are told that the remainder is 26. So this 2 is your root, and this is your remainder. Okay. So right here, where the remainder goes, I'm going to put my 26. What can I combine with a positive 2 to get a 26? And that would be a positive 24. Working forwards, we multiply, but working backwards, we're going to divide. So 24 divided by negative 2 is negative 12. What can I combine with negative 4 to get a negative 12? So ask yourself, what can you subtract negative 4 from to get a negative 12? And that would be a negative 8, because negative 8 minus 4 is negative 12. All right. Negative 8 divided by negative 2 is going to be a 4. And now we've got our little mini equation. So let's see. We've got k minus 2 equals 4. Add that 2 to both sides. We get k equals 6. And let's see if we can get the same thing if we do remainder theorem. Okay, so let's see, our remainder is 26. We're going to set that equal to x cubed plus k times x squared minus 4 times x plus 2. All right, we know our root is negative 2, so wherever there was an x, we're going to replace that with a negative 2. Negative 2 cubed, so negative 2 times negative 2 times negative 2 is a negative 8. Negative 2 squared is 4, so we get plus 4k. Negative 4 times negative 2 is a negative 8. Then bring down the plus 2. Now, obviously, you can use Desmos, but I'm just going to go ahead and work it out by hand. All right. Actually, see, this is where somebody in class, if I was doing this in class, I want to say, Miss CP, negative times negative is a positive. Negative 8 plus 8, they cancel each other out. So we're left with 4k plus 2. When I subtract 2 from both sides, I get 24 equals 4k. And then when we divide by 4, 24 divided by 4 is 6. So whether we do it by the synthetic division in reverse method, or we do the factor theorem, not factor theorem, but remainder theorem, we get the same answer. All right, so our last problem is our U-try with this right here. All right, so let's say that you are given the polynomial 2x cubed minus 3x squared plus kx minus 1. And you're told that p of 1 is equal to 2. Alright, so choose a method and find what k is. Alright, so if you'll pause the video for about 4 minutes. Alright, so let's see how you did. Now, I like synthetic division, so I'm just going to do synthetic division. Here, I know my root is 1. My coefficients are 2, negative 3, k, and negative 1. Now remember, if you're told this is a factor, then instead of having a remainder of 2, you would have a remainder of 0. But these last couple of problems have been different remainders other than a 0. Drop in that 2. 1 times 2 is 2. Negative 3 plus 2 is negative 1. 1 times negative 1 is negative 1. We've hit our roadblock, so we're going to work backwards. I know my remainder is going to be a 2, so right here I'm going to put that 2. What can I subtract 1 from to get a 2? Well, that would be a 3. If working forward we had to multiply, then working backwards we're going to divide. So 3 divided by 1 is 3. Here is our little mini equation that we needed. So we got k minus 1 equals 3. Adding that 1 to both sides, we get k equals 4. All right, if you'll put your name and date on the paper and make sure you submit it.